Hello. Good morning, everyone. And for those who are joining us from overseas, good evening to you all. We warmly welcome you all to today's session on this very interesting topic on behind the scenes of engineered fashion. I'm Krishmi, and without taking much time, I'll quickly introduce our speaker today. Today we have Dr. Cagri Tanriover, who is an electronics and communications engineer and has received his master's and doctoral degrees in Lancaster University, UK. And he comes with over 20 years of industrial experience in Europe and the US with award-winning contributions to the ETSI's Tetra standard as a technical lead in multiple specialized task force teams. Dr. Chara's technical expertise spans a broad range of areas, including wireless communications, data security, digital signal processing, and wearables. And currently, Dr. Chara works as a staff research and development engineer at Intel Labs, working with millimeter wave band radar, RFID, and Wi-Fi technologies. Before joining Intel, he's also co-founded a startup designing and developing an industrial wearable. Dr. Chara has over 20 patents to date and regularly mentors and provides technical IP training to Intel engineers. He's also an IP committee reviewer and helps Intel expand its patent portfolio in autonomous platforms and technologies. And luckily for us, Dr. Chara has agreed to take time off his busy schedule to be here today and share with us all whatever he has learned during his journey and how engineering applications extend even into atypical industries, introducing the inconceivable fusion between technology and fashion. And before we start, just wanted to make a couple of courtesy requests to ensure we have a smooth session. We would really appreciate it if you could keep your mics muted during the session. And if you guys have any questions, you can raise your hand or you can surely drop it in the chat so that we can take them on at the end of the session. All right. I think we can start. Dr. Chara, over to you. I hope you're here.
Hi, Krishmi. Thank you so much for the wonderful introduction. It's very humbling. And thank you for having me and for hosting this talk. And it's my great pleasure to be here. And I've been looking forward to this talk where I'll be happy to share some of the insights and one of the more compelling projects that I had during my career. And without further ado, I'll just share my screen. Please let me know if you're clearly able to see it.
Whisper, Doctor.
Yeah, perfect. So thank you, everyone, for taking the time for being here. I'm certainly very pleased to be here. And when I was thinking about what to actually talk about during the session, I was going through a number of projects that I was involved in the past, and basically I wanted to pick something that was special. Basically, I wanted to pick something that had a lot of different elements that would be interesting to actually deliver in the form of a talk, but at the same time, from the perspective of the audience, would be interesting and entertaining to listen to as well. And for today's talk, I picked this particular topic because it actually embodies multiple things: multidisciplinary research and development that brings technology and fashion together to start off with, and certainly it's a worldwide impact at many different levels that I'll also be able to talk about today. And also, I wanted to share a project that had some element of magic, surprise, uniqueness about it as well. I didn't want to sort of bore you to death with all the technical ins and outs. I just wanted to actually entertain you while actually providing some informative things and takeaways as well, hopefully, that I think you will find useful in your future projects and tasks as well. And so today, basically, what I want to talk about, some of you may already be very familiar with this project. That got a lot of coverage in the media. 2015, 2016 timeframe was like when it was at its pinnacle. So you may have seen most of the things there. But today, I'm not going to go through all of that. What I want to go through today are really the unseen, like the behind the scenes, truly behind the scenes things. And really, I want to talk about the journey that didn't have much coverage in media. So I actually want to share those ones. The reason why I want to do that is really the takeaways that I would like to share are really in the journey itself, not really in the media part of it, where we were, where we actually arrived at the end as a destination, but really the journey itself. That's where I think the gems are. And I want to share those ones with you. And hopefully you'll find it equally entertaining and informative as well. So let me just and also the thing I like about this, like I mentioned, the element of magic. I included a quote there by Robert Heinlein, an American novelist, and basically, one man's magic is another man's engineering. And I think we're all very fortunate to be working in this field where we have the power, we have the resources, and we have the creativity to create things that look nearly like magic. And I really love this aspect of my job. And wherever there's a project or a problem or a challenge that allows me to experiment with near magical experiences that always all people, I want to be there. I want to be part of it. And that project certainly brings all of those elements together, as I will shortly share with you. So basically, I want to start, give you a little bit of background on how this all started. Basically, this is a project in collaboration with a fashion name called Ezra Tuğba Sisters in Turkey. They have a great name for themselves, and they're also very interested in bringing innovative approaches to their actually haute couture dresses and designs. And Intel at the time, in 2015, 2016, was very much invested in the wearable space. And a new SoC called Intel Edison, which most of you may already have heard of, was actually rolled out. It was just released. But really, we wanted to show the capabilities. We wanted to share it with the developers, like variable developers, of what this chip could potentially do. But we wanted to do it in an extraordinary way to actually capture and engage people. We didn't want to just, have regular sort of like development kits and just tell people like on simple project. But really, we really wanted to push the envelope to show them what was really possible in a compelling way and memorable way as well. And Ezra Tuğba approached us as soon as they heard about this new technology. They were very excited. They actually reached out to us, and we sat down there and we just tried to actually develop a vision together. And this shared vision really was to actually show Intel's new wearable technology and to see how we could merge the fashion, basically the high-end fashion design that Ezra Tuğba had at their disposals, in a compelling and an unseen experience sort of fashion, something that would really awe people. That's what we were going after. And we were both very excited about this prospect of where this could potentially lead. But we had no idea, where this journey would take us. But we were really excited to start. And this really brings the first takeaway that I would like to share with you today. So when you got like a multi-stake holder kind of projects, tasks, whatever it may be, the critical thing is, if you want to create a big impact, you really need to make sure it is founded on a shared vision that really excites everybody, that really inspires all of the parties that are involved. And surely I attribute the success of the butterfly dress and its impact to one of those takeaways, which I think is critically important. And basically, while we were going through all these ideas, we just started with a blank slate, and we just looked at it and said, well, okay, where do we start? What do we do, basically? The what was the very important and the first question we had to ask ourselves with this thing. Obviously, the sky's the limit, but we also have some criteria on. We want to make it compelling and unseen. We want to excite people. We want to inspire people. So that was a real challenge. And one avenue we took was to really look at what Ezra Tuğba already had there in their collection and how we could potentially integrate something to actually bring that new experience to their dresses. And at the time, they were working on some new collections based on Far Eastern theme. The dress that you see there is basically like has some wooden shutters, like small shutters around the dress. It sort of has like a samurai kind of feel to it. And they were wondering whether it would be possible to bring some dynamicism to this dress, because at the time it was a very static dress. And this was one avenue while we were going through the collection from Ezra Tuğba. And the other avenue we took was really, at the time, wearables were like a very interesting space that excited a lot of people. And with that came a lot of different light-based technologies, like electroluminescent wires, cables, fabrics, certainly fiber optic fabrics, some bendable, flexible displays, etc. That was all very exciting. And people were very busy actually integrating these technologies extrinsically to the dress. What I mean by that is really literally just taking a needle and a thread and really sewing these things to different parts of the dress to bring about new experiences, obviously. At the time, we didn't have access to e-textiles, smart yarns, etc., things like that. None of those exotic things were accessible at the time. So that was the level of integration that people were going after at the time. So we were also considering these options, and we actually did experiment with some of those interesting technologies ourselves. And basically, during our pathfinding, we also looked at another area where 3D exoskeletons were becoming very popular. With the 3D printing capabilities ever improving, that was like a very hot area, hot domain. So we actually looked at it from multiple angles. Do we actually create an exoskeleton that someone can actually wear instead of the dress itself, or do we actually go for something that we integrate to a dress, basically, as sort of like an attachment, like in the bottom right examples that you can see. So while we were toying with all these ideas, really, nothing truly excited us about it until, we started seeing some interesting dots in the space that could potentially be brought together in a creative way. And when you look at fashion and when you want to create a compelling dress, and when you obviously use Google to look at things what's already out there, like images, videos, and everything, it's very hard to miss things that are related to butterflies. Butterflies are quite a central theme in fashion. Like the example that you see on the screen there is basically like a butterfly applique that is spread across the dress, but they're static. They're just simply fabric materials that are sewn to the dress. And you get to see a lot of things that are based on the butterfly. While this is very compelling and interesting, there's some element of beauty that's associated with it that people actually are drawn to. So it does make sense from one angle of using the butterfly theme, but at the same time, we just want to bring that unseen and the compelling experience piece into it. So the question was, how do we do that? And while talking to the designers, they were constantly sort of like scribbling and drawing and like sharing their findings with us. And this is kind of the vision that they had. I mean, this is one of the designers from Ezra Tuğba that they shared their drawing with me. And they had this vision of having some dynamicism, some motion, something that actually allows the butterflies to move freely in association to the dress as well. We wanted to have that, keep that link still, but we wanted to bring some dynamic structure to the whole thing, in addition to what was done previously there, right? And but we really didn't know how that would play and how we could potentially do this, until we actually came across another interesting product by a French company called Magic Flyer. And, I got actually a few samples here that I can actually do like a real-time demo for you as well. And it's basically a very simple paper butterfly with a rubber band around it, as you can see in the video as well. So the way it works is they've originally designed these things to actually, you can just wind it like so. And let's say you have an invitation, could be like a birthday invitation. Once you wound your butterfly, you place it carefully into the invitation itself, you close it, you put it in an envelope so the recipient actually gets this. And when they open this, all of a sudden, the butterfly actually jolts off the envelope. There's that element of surprise and interesting, and you can actually use multiple butterflies to even make the experience richer. So it's quite clever, very simple, quite clever. But now, as you can see, like as we're trying to build on this butterfly themes, things are like something's starting to emerge, but really we still don't see the light at the end of the tunnel. We really don't know where we're going with this. There's some ingredients there on the table, but we really don't know how to bring this whole all together in a coherent way, right? And the one thing that you can see here is, compared to the previous slide, when we were talking about the technologies, electroluminescent lighting, fiber optics, and all these exotic technologies, we started going down an interesting path, and we started talking about ingredients that really just didn't make sense initially, right? This is not one of the first places that you look at, right? And but it led to something that I will describe later on in the slides, and that brings me to the second takeaway. Sometimes the novelty we seek, the impactful novelty that we want to bring about, requires us to change the perspective, the perspective that we're looking at the problem from, and sometimes we need to locate and connect the right dots. And that's what we were really doing at the time. We really didn't know. But, when looking back in retrospect, this is what we were really doing. And that's what actually led to something that was compelling and stood out from the rest, right? We basically took the path that was not taken before us. And then once we have all the dots, the question then becomes, okay, how do we connect them? Okay, we've got some interesting ingredients here, which sort of starting to make sense, but we really didn't know. We couldn't answer the question of how, which was quite critical. Everyone was excited about this, but nobody had the answer to the question how, right? And this also brings me to another important takeaway here. Sometimes as engineers, we like to play it safe. We want to see the light at the end of the tunnel. We know before we design something, we look at the feasibility. If We have all the tools under our belt in terms of implementing something. If it is a project that we've been there before, we've seen before, we're excited about it because there's hardly any unknowns. Us as engineers, we love things that, the less unknowns there are, the better it is for us because we know we're going to nail it. We have that confidence. This is our comfort zone. But at the same time, if prematurely, for example, we were to sort of rule all of these out purely because we can't find the answer to the how question at this stage when we were looking for the what, then we would be prematurely cutting innovation on its path, basically. So we just discard this, something with a potential, and move on to something else that was safer, but probably less compelling. And that does bring me to takeaway number 3. Sometimes when we are actually trying to find the what, or trying to answer the question what, we should probably not worry too much about the question how at that time, because that really stops the innovation from happening. So we really need to time it well. We really need to put these in 2 different buckets and potentially worry about the what and worry about the how later on, right? That's really an important takeaway, I think, in a project like this one. And once we actually have the what at a 10,000 foot view, there's still details to sort out. And those ones actually come in the set of requirements. And for us, it was pretty simple. There are really 2 buckets for us. One of them was the technical requirements piece, and the other one was the dress design requirements thing. And you can imagine, when engineers work with designers, it's completely different worlds. They're very separate buckets, and it's very hard to work together because everybody's working towards different set of requirements. And as you can see, you can potentially put down some of the requirements independently. I could just write the technical requirements in my bucket, and the designers could write theirs in their bucket, and that's okay. But there are areas where you have these crossover and overlap, where you really need to one requirement on one bucket actually has to drive the other requirement in the other bucket. That's where you really need to communicate and talk. And basically, I want to give this as an example. For example, if you just look at one of the requirements that says something like batteries need to be placed behind the knees where there is space. Now, this is an interesting requirement because the dress we're dealing with is an haute couture dress of a very small, I think it was size 7, and there's hardly any space in the dress to actually add anything except the wearer, because these dresses are made to fit. And so the size and everything is pretty fixed. You don't have the luxury to play with it. You can't make it large and baggy, because then the designers will complain and say, well, this is not aesthetically pleasing. This is not where we want to go with this. So that's really out the window. So you can't really stretch it from that angle. So you really have to be very creative about how you do this. So we knew the model wouldn't actually be sitting very comfortably, that person wearing the dress at the time. This is like a showpiece. This is not something that was designed for comfort or everyday use, right? Also, knowing that constraint, we said, okay, probably when that person's standing, that space will be available, and we basically place the batteries there. But when we actually put a requirement like that one, that actually creates another new requirement for the designers in their bucket, because they want to make sure the dress, actually, however we're going to place the batteries in the dress, it needs to follow the form factor of the dress. We should not actually intervene with the integrity of the dress, with the wholeness of the beauty of the dress as well. So basically, that actually creates an additional requirement for them to actually create these fabric pockets, which need to be seamlessly integrated into the dress so that the batteries actually stay in place, they're stable, and the weight is actually balanced across the dress, right? So the dress doesn't sag as the person's wearing or walking around, right? So then, once that new requirement is generated, it just added to their bucket all of a sudden. Something that wasn't there initially gets added because of the technical bucket. And by the way, this is a bi-directional way. While we're iterating, it doesn't only work one way, but it works the other way as well. Like in this example, the designers decided that, in one of their requirements, they wanted to have the chest piece open and exposed, right? So there wouldn't be any fabric in the chest area of the dress. There would be like a neck piece, which had some implications, believe it or not, in the technical bucket. Initially, something like this, you wouldn't care much. But for me, what that meant was, that means if there's going to be an empty gap there, no fabric, there's no surface to work on. So that means we cannot put any butterflies on the chest area. But at the same time, we don't want to actually put it randomly elsewhere on the dress, but somewhere in proximity to the chest, which is basically shoulders or the neck area. The neck area wasn't an option because it's a very narrow area. So we opted in for the shoulder area, which is requirement number 4. And to be able to do that, when you look at the shoulders and the chest is a flat surface, right? So placement of the butterflies, however you choose to do it, is very different than putting it around the shoulder area, which is round. There are curves. So you have a form there that you really need to follow. So that means whatever platform we were to implement, we had to basically adhere to the ergonomics as well. And guess what? Those two requirements get added to our technical list. So, and the story goes on. This was just like, a couple of examples there to show you how this interplay exists between different buckets of requirements. And one thing to be careful here, though, is it's very easy to push back on some of the requirements because, if a designer tells you to do something, you say, well, can't you do it in another way so that my technical bucket becomes easier to handle? Why do we have to do it that way? When you start to question their requirements, that's when the friction starts to happen. And and likewise, when I actually do the technical bucket and push my requirements their way, they could say, why just can't you do it that way? Can't you use a shorter cable, longer cable? Another thing I like is smaller battery. Why don't you use solar panels? Just do like some energy harvesting or what have you, right? They could just actually start to propose alternative. I could get a pushback from their end. But guess what? That doesn't work. That just creates friction. You need a seamless and a good coherent communication between different parties for this whole thing to work. Therefore, the fourth takeaway from this is really embrace the requirements rather than finding creative ways of cutting corners so that your bucket is satisfied. This is team effort. You can't just, be happy that, you don't want to put a tick box on your bucket while the second bucket, has no tick boxes at all, because then the project is not going to fly. So therefore, you need to embrace the requirements, and rather than actually pushing back, what you need to do is to focus on options and alternatives to create a working solution where all of those requirements are actually successfully met. And there is no friction while you're actually communicating and talking with all of the stakeholders in the project. And once we have sorted out what's list, basically, then slowly start moving to the how piece, the execution piece, right? And here I just want to give the takeaway right off the bat. Basically, for us, the most important thing was to highlight, really look at the high risk item right from the start, and then work backwards. Like, let's try to highlight that. Let's find that, identify the high risk item, and let's resolve the how for that piece first. And for us, really, one thing clearly stood out. Everything else, like the battery, the power requirements, cables, etc., like, the connectors, all of that was either sorted out or we knew roughly how to sort it out. But the main pain point for us, stuff that really kept me awake at night, was really one piece. How does the physical housing and the release platform of the butterflies is going to be actually implemented? How are we going to achieve that? That's really the crux of the problem there, right? That's where really the main issue lies. So once we identify that, then we start building the house that actually worry us around that one piece. And as you can see, the list grows there, right? Gradually. There's like quite a few pieces there that is only associated with that high risk item. Each one of those has to be addressed for the dress to actually work the way we envision it. And once you lay this out and expose all of these, then you're actually basically are working with the problem in the background. It just comes with you everywhere. Any designer will be able to tell you that. A lot of us has experienced this in many different projects, big or small. We've gone through this. When there is a problem that we can't solve, it just nags us. It's always at the back of our mind. We go everywhere. It just, when you're off work, it just comes with you. When you sleep, it just comes with you. But the thing is, that's part of the process, right? You're working on it subconsciously. You're always trying to come up with alternatives and potential solutions to this one. And in my case, certainly, I remember exactly where that aha moment was. And it just happened while I working through the problems, for a few weeks in my mind. I was on the way to a conference in Cyprus. This is exactly the road that I was sort of looking ahead. I was in my car. I was just driving down. And that's when it hit me. That's when I thought I really had something that could potentially work. I didn't know it would, but given all of that and given the time I spent on it, I thought I had something basically that was there. And really, at that moment, I couldn't wait to get back to my lab where I could really start experimenting things, where I could actually give some proof points on whether this thing could work or not. I was very excited about it. And then basically, as soon as I got back, this is the part where you go for the rapid prototyping. This is really the exciting stuff, because you really want to see whether it actually works or not. In your mind, it has. You can see the picture, but really you want to see something tangible that actually shows you whether it works or not. And at this stage, really, you are not looking for a perfect solution. At this stage, speed is all that matters, because you really want to get that proof point as soon as possible. In case it doesn't work, you have to iterate further. Obviously, time is of essence there, right? You might end up, you don't know how many iterations you're going to go through, but time is of essence. So you have to do these things quickly, right? And whatever I could get my hands on. We didn't have like many resources, and all of the items that I would need weren't there, but I had to be creative. I mean, I had a 3D pen that actually helped me put this custom hook together, for example, that I could actually fit into the end of a servo motor. And the servo motor just came from one of our kits, basically like maker kits. It's like a standard servo. It's not perfect, but it'll do the job. And the PCB, you see, there's actually a two-piece thing. And actually, it was like from one of our older projects, but it was just there. Like, it was like the perfect platform. So I soldered it together. I cut it to size as I needed. And basically, the like all the braces and brackets, for example, this metal piece you see there is actually used to be a paper clip. And it was at my disposal. It had the right length, and I could just, shape it the way I wanted it. And I grab a few screws. And really, I was working like fast, like, I had that sort of line of sight where I was just really like moving forward fast to implement this thing, to show whether it would work or not. And I fortunately had one of those basically samples as well at the time. I said, like, this is perfect. I can have my own butterfly launcher almost in a second. And really, what I did was, this is really the moment where I put this thing together, and I found it in one of my archives. And there, this gave me the opportunity to experiment with the platform, like really place the butterfly, how long it takes to place this in place onto the platform itself, whether it actually stays, it has the stability that's required, how responsive it is, how well actually it works or it doesn't work, how stable I think it will stay on the dress as well. And so those are the kind of quick answers that you really need with this rapid prototyping phase. And as you can see, like, you use our boards there. That was meant for, like, again, maker kits. Everything just came together very fast. And really, this is the moment where I was sure that we had a solution there. That's the moment. That was the verification moment for me, right? And really, that's where the importance of rapid prototyping, as the name suggests, it needs to be fast. And all you want is just to look at the core functionalities, try to create a prototype where you can fully or partially prove some of those points. It doesn't need to be perfect. You don't need to overthink this. And you just need one or more proof points that's going to actually take you down the right path. So it's important to do that quickly for that purpose. And basically, once you have sorted out the critical how, then you just continue working down the list. And there's obviously like many items at the stage that you need to address, right? And for example, when Edison actually came, sort of like this size, I have one sample here, right? And it would typically be embedded on a platform like this big, like a baseboard that you would have. And it's right there, it's just embedded on it. It has got all the IOs, all the connectivity, all the power that you need. This is a perfect platform for testing ideas, like you saw in the previous slide. And the good thing is, with these platforms, you can actually plug and play. You can put various breakout boards on it. You could actually have expanded IO capability, which is beautiful, which is perfect for the purpose. But the problem is, the dress doesn't have space for this kind of thing. So even though you could actually bring a solution, a working solution very quickly, this is not fit for purpose. So what we had to do was to go for something a bit more suitable, like a breakout board, right? That we had to design, something that is of comparable size to Intel Edison, as you can see there, right? Something that we can just sandwich together like this, very easily, quickly. It is small enough to fit on the dress. And it works beautifully. Now, the problem is, like afterwards, like a few months after Edison was rolled out, I mean, this is only about like a few weeks after the Edison board SoC was made available. So there was no chance for us to get access to any breakout board like this. But some of you may already know, SparkFun, after a while, they actually came up with these very nice, slick boards fit for Edison, designed specifically for Edison. And when you compare what they came up with and what we did at the time, they're pretty much similar, right? They look very similar, and you could just later on you could expand the capability. You could just sandwich more of those boards together behind an Intel Edison to do whatever you wanted to do, depending on the functionality and the features that you want. So this is all well and good. It's a fantastic platform, but it was no good to us at the time because it was not existent. We needed something now, right? So that's why we actually went ahead and designed the Intel's first Edison breakout board, basically. And we got this manufactured using an OEM, which was perfect. But the problem is they give us a lead time for populating these boards, about a month. We didn't have a month. We needed this working in a week. So we didn't have that option. So as you can see, time and resources was never been on our side in this project. But so what I ended up doing was, this board actually has 55 different components, some of which you can't actually see with the naked eye. So you do need a magnifying glass and a microscope and good soldering skills to get in there and at least get two of those actually in a working condition. So that's what I did, because that was the fastest way forward, right? But that wasn't all, right? That's only part of the problem. There's the cabling, which is very important. And the cabling that I'm talking about is like fully customized for the dress, for the dress size, for the dress's model. And as you can see, like clearly laid out here, this is where we put our Edison breakout board in the Edison itself. These are our like battery packs, and these are all the cabling that we have to do on the connectors, and they all have to be tested, of course, right, for proper operation. And where we really want to get to is from start to finish, is to see that technology on the dress. Everything works beautifully on the table. On the bench, everything works perfectly. But knowing the challenges and knowing what we knew at the time, this is the area that, make or break point is putting everything on the dress there. And sometimes, the prototype cabling, the length and everything may not be perfect. But again, this is part of the rapid prototyping. We just want to get there fast. We want to see what the problem areas are. And it took us quite a few iterations to actually get the stability we wanted on the dress. There was a lot of back and forth between the designers and ourselves to make sure this whole thing actually worked after a few set of iterations. And really, time was never on our side. Resources were never on our side. We were just, running on the clock, because the designers initially told us they wanted to make sure these dresses appeared in a runway show 3 months down the line, like from start to finish. And I, initially when I heard this, I said, this is impossible. There's no way. There's so many unknowns. Nobody, in our team has worked on something like this. So there's a lot of unknowns, but we wanted to take the challenge. We wanted to go for it, right? And sometimes, the resources and tight timelines, tight resources are hard things to deal with. They throw you out of your comfort zone. They're not nice things to have. Mentally, it's not a nice thing to have. I would love to have a lot of resources to work with. But guess what? Sometimes the opportunities for growth and innovation are exactly where those constraints are, where the time constraints are, where the actual physical constraints are. So if you're happy to take the challenge, that's where you're going to innovate and grow as well. And certainly that cycle gave us a lot of that, more than what we would expect for, right? And, we learn how to work with the designers. The first time we're integrating a technology into a dress. We're looking after the aesthetics, but at the same time, we want to make sure the technology works as well. So there was a lot of conflicting interests as well at the time, and we managed to bring them all together in a coherent way. So that's where the opportunity was. And this actually helped us move forward. And obviously, when you work things like this, when you hear the word backup, it doesn't only apply to software and hardware. I can promise you that. It also applies to wearables and even dresses like this one. As you can see, this is the first version of the dresses that we actually demonstrated in public. And the reason why we have two is we also know things go wrong. This is a very new opportunity. Even though one dress worked, doesn't mean it's going to continue working at the same rate of reliability that we would expect. Therefore, we have to be safe. And the second dress was there. Okay, that gave a good opportunity for the designers to create another dress design, but for us, it was really a backup. In case the first dress failed, we really didn't care on the face of it which dress was used from an aesthetic perspective, but I knew exactly the same technology in dress number 1 was in dress number 2 as well. So if something failed, we knew the show would go on, right? So that's why we created a different version. And we created totally new versions as well. This is probably the one that you've seen out there. This is the most recent one we created. Again, as you can see, there's 2 of those. There's never one. These are identical, but we always go with a backup moving forward. And each design actually improved. Like, this cycle also helped us create different perspectives and think about different ways of implementing things from a robustness perspective, from an enriched experience perspective. It just gave us the space, right? And just to give you a couple of examples, like the initial platform I've showed you that was built on PCBs, for example, very rigid, not, you can't really bend it, you can form it. Then we actually started exploring different materials like the metal mesh that you see in my hand. The good thing about this one is you can shape it any way you like. You can bend it, warp it. It's pretty strong. It's a robust kind of material. That you could actually, the good thing is because it's a mesh, you can sew it anywhere on the dress. You can cut it to size, You can create shapes that can blend in with the fabric very easily. And the other good thing about this one is, for example, you can actually put your servos, you can glue the servos and they will remain in place. This is quite a robust way of actually holding them in place. But also for the shoulder problem I mentioned earlier on, it just beautifully works and bends over the shoulders in any shape you want, right? So that was one type of innovation and change we introduced in the dress number 2 there, right? We also implemented that for the first versions as well. And the other part was like obviously the servos. Servos are one of the most headachy parts of this project. Like when we first started, this is your typical servo that you find in any maker kit, right? A very standard piece of kit. It's robust, it works well, but the problem is it's loud and it's clunky. It's very, when you look at the size and volume, it's very large compared to the butterflies we had there. They actually show when you put it on the dress. So the aesthetic, from an aesthetic perspective, it's not very appealing. So we went out hunting and say, okay, what is an alternative to this thing? And then we came across what's called nano servos, right? Which is like a fraction of the size of this one, right? And its acoustic noise is much less. It actually fits in well. It's got a transparent cover, which actually blends in very well with the dress, right? And it works pretty well, very reliably. So these, like in the follow-up versions, we start to use these servos rather than the standard one that we could get our hands on. So basically our design and the concept and the way we viewed this actually improved very well over time, right? And that helped us a lot. Our original design improved after each show. Obviously, my sewing skills improved with it. This might be funny, but for an engineer to say, but believe it or not, when you're working with variables, be prepared to get your hands on a thread and a needle, and sometimes to get in there, at least to relocate or reposition some of these cables and servos, because it does help. The reason why it helps is it gives you speed. It gives you accessibility. If I wasn't able to do that, then I would have have to have a seamstress with me all the time, just sewing stuff as I'm positioned, and it's not very practical. And you got to be practical if you want to move forward fast with these things. So and now that I can sew as well, I'm not complaining. It's always a good skill to have. You never know, I might work on variables again in my future life. But the question that might come to your mind is basically, okay, well, since you already had something that worked, right? Why bother trying to improve things? Why sort of push it yet another step forward? And this gets asked a lot. And the reason is basically things that are in your control and things that are out of your control. And I want to cover those a little bit. Basically, when we first started, the original design was a Bluetooth controlled dress, right? So you would have a typical mobile phone application where you got this Bluetooth control, which would connect to Intel Edison on the dress, which would in turn control all of the butterflies and how they were acting, right? So that meant you needed a person to control the butterflies and another person to present the dress. So it was a two-man job. This was all very good initially, because initially all our shows were we were always close, the operator was always close to the dress. This was sort of like a large-ish room, I would say. But sometimes, as we're doing more and more shows, the environment is also changing outside. We get invited to these different venues, and all of a sudden, things that used to work actually start to give problems. And the main one is, for example, if you're in a runway show where there's multiple models walking, on the catwalk and everything, then you can't walk with them. That's just not possible, right? So you still have to stay put while they go, and then you just need to make sure these things actually launch on time. The butterflies actually work as expected. But then we were actually getting these frequent disconnects, which was actually really intervening with the experience piece. And sometimes some of these problems you just find out on the field. You can always prepare, or you think you're prepared for it, but sometimes the field tells you what kind of changes you need to incorporate to make sure everything runs smoothly. So then we had to go for the Wi-Fi alternative, which again Intel Edison at the time was providing to us. Say, okay, let's just use this feature and let's see how well things actually get improved for us. And so we incorporated the Wi-Fi control the butterflies. Things did improve to a large extent. We got the range that we were looking for as well. But the problem is we were getting these intermittent trigger failures again. And then when we actually looked at the problem and did some tests, when you look at runways and these the venues that these shows are run, it's very much metal-friendly environments. People love putting those large frames with heavy metal pieces. to hold on the lighting that needs to go with the experience, right? So they need like a strong structure to do that, and metal is the answer. But unfortunately for us, metal is not the answer when it comes to establishing a reliable wireless communication with the dress, right? So that was an issue. So because this problem was intermittent, we were thinking, okay, what is sort of like a fallback that we could put it here that would actually allow us to use it when we needed it? And the answer was really like a very simple but effective solution. It's sort of like an emergency switch, as we call it, a panic button, as we used to call it. Basically, is a button that is strategically placed on the waist level of the model, where the model would proactively trigger it when she knew that the Wi-Fi wasn't working. So there's like these things are timed, and she knows when to expect things to happen. And if it doesn't happen, then she's authorized to hit the panic button, so to speak, right? And here's the moment when you're actually seeing one of those instances where our Wi-Fi link has failed, and she actually activates the button, as you can see. As far as the audience is concerned, the experience is still the same, more or less the same. But as an engineer, you got to think about these potential problems. The show like this, it must go on, and you got to make sure it goes on. But sometimes that means you have to be creative in how you actually come up with quick solutions and fixes to those problems. Some of these the problems that I've talked so far, they're prompted by technical difficulties, right? But some of the changes that you need to make actually come from completely different reasons. And one of them is like logistic and the comfort of the person that's wearing the dress. And initially, for example, when we were doing our shows, they were quick. The model would get into the dress, and 20 minutes to about 30 minutes, she'll be out. Like, the show would be over. She just gets the dress, she gets on the runway, butterflies fly up, and she walks back. Very quick, very quick. So the model wouldn't have to wait as long. But as we were actually getting into involved in more like complex shows where people were giving speeches, they were getting Q&A and everything, and the model's like right in behind the scenes, and she is like standing there. Like I mentioned, you can't sit. When you're in the dress, it's a short period of time, so it's a reasonable amount of time to keep someone standing. But if you keep that person standing in that kind of dress for about an hour, then it becomes a problem. Those are the kind of problems we were having. We wanted to at least give the luxury to the person to be able to sit, to take weight off their legs, right? It's very obvious, but sometimes you just don't worry about these things. But when the time comes, you have to worry about them. And that actually led us to do some cable rerouting, again, battery and enclosure repositioning in the dress as much as we could. Like, some of those sizes we actually managed to decrease as well further on. So we were constantly like in this, research and development mode, like, as these problems emerged, we were like trying to sort of address them. We were being very reactive about them, right? And basically again, as you go to more shows, there's another problem that you don't actually initially think about or worry too much at the initial phases of the project. As the dress is becoming popular, people are seeing the videos, people know the dress, they see the dress, they know exactly what the dress will do. So the problem there is the experience becomes a bit stale. It becomes old. People aren't finding that engaging anymore. And that's the moment when you need to actually refresh things, right? And when you need to think a little bit outside the box and ask yourself, okay, what else can we do to change the experience so that people can re-engage, right? And we looked at it from the autonomy and the interactivity angle first, right? So can we do some like a change to the dress so that people would re-engage with the dress again? And the answer lied in a simple ultrasonic sensor, something like this, basically very simple. And we would typically position this on this dress. It was on the chest area. It was sort of hiding behind sort of like a flower embellishment, because these things like they're not particularly attractive. I mean, with electronics, you don't actually get the luxury of having attractive looking parts. We all know, right? So you got to make them. You got to either hide them or make them look attractive somehow. And that was our solution at the time. Sort of like a flower embellishment on the dress was the answer. And what this ultrasonic sensor did was to add this. It's a simple way of doing it, but when someone, the watcher viewer was in proximity of the dress, then that person would effectively be controlling when the butterflies would launch. So nobody had buttons anymore. Nobody was controlling anything anymore, but the person who was trying to interact with the dress was controlling the whole experience. And that anticipation that the butterflies would launch at some point was the exciting piece for people. Then say, oh, well, the dress is smart. The dress knows that I'm actually close, I'm nearby. So it actually is reacting to my action kind of thing. Believe it on. Even that simple addition really took the experience to another level from the observer's perspective. And similar to this one, there was another problem. That problem was, okay, when you think about the whole experience, you approach the butterflies launch off the dress. It's the climax is about 1 to 2 seconds, not long. When the butterflies are out of the dress, there's nothing else left on the dress for people to keep on looking at it or to interact with it. That was the problem, right? And it typically takes about 15 minutes to sort of put the butterflies back together to replay that experience. So that's a long time, right? You lose crowds. People won't just sit around for 50 minutes just waiting for this thing to to repeat itself. So we also needed to come up with something to make this experience a bit more compelling. And the answer we had was then, okay, let's use another set of butterflies, like perched butterflies, and that would flap their wings. And the actual demonstration you see there is like the first prototype that I developed that could achieve that one. Basically, we worked with different materials like this one, like plastic ones that's bendable, just doesn't tear, is quite robust, by putting different cables and bring some tensions into the wings. And again, using the servos to sort of make them flap, look like just like in nature, as much as we could replicate it. And there we had the time when they would start flapping the wings, and we could also control the speed at which they flap their wings. So there were two parameters there. But when we remembered that, we actually had an ultrasonic sensor as well that's already on the dress, we said, okay, let's just combine all of these. Let's just get the butterflies to start reacting when someone approaches the dress. The perched butterflies would start flapping their wings. So all of a sudden, a dress that looks very static starts to react to the person approaching the dress. The launching butterflies are still on the dress. So as the person comes closer, the wings actually start to flap faster. So, that kind of interaction with the user, the observer, actually has another meaning now. So they actually can just step back, come closer, and observe how the behavior of the dress is actually changing. And that engages them a lot. If they approach the dress even further, at the last moment, that's when the butterflies actually launch. But when the butterflies actually launch, the person is still able to interact with the dress, moving back and forth, observing the perched butterflies. So all of a sudden, this simple idea extended the length or the duration of the experience and the amount of time people would spend around the dress. So it's like bringing all these ingredients at your disposal actually helps you move forward and actually enrich the experience in the different dimensions. And basically, at the end of it, both dresses actually had multiple software versions with different feature sets and additional feature sets. And when I look back at it, we went only until about version 3. But if they had the project continued, I'm pretty sure we could have kept on adding and making this even longer. So the changes and the additions are almost endless. There's always room for improvement, even on projects that seemingly don't have much content to it, right? Doesn't matter. This is independent of the size of the project and the context of the project, but there's always room for improvement in everything that you do. And it's just a case of how you look at it, how you perceive what you're doing. And basically, when we look back in time, the journey of the butterflies, the journey was an interesting one because it took us places where we never initially imagined. We never thought it would go for that long. We never knew it would just go and show up in so many different shows, and we never knew we would develop multiple versions of the same dress. For us, it was just one version and end of the project kind of approach. But the reaction of the crowd, the public, and the PR around it actually pushed us forward for about a year and a half to 2 years. And to this day, still, I am able to talk about the project. There's so much to share there, and it's just an interesting journey, right? And it was the world's first haute couture dress with Intel Edison, and it was the first show actually happened 3 months after the time we decided we were going after the butterfly theme, and which is quite remarkable, which is a very short period of time to put the first prototype out there. And the dress has traveled quite a bit, and it's gone to places like London, Milan, Paris, Madrid, Istanbul, Barcelona, all those places. It's seen it's been seen by thousands of people. And for me, the most amazing thing was the awe in people's eyes. They never failed to put a smile. When they saw the butterflies airborne, when they actually saw the perched butterflies flapping their wings, they were always amazed. Even though they had seen the videos before, they knew exactly what the dress would do. I think that's where the magic element in this project is. It really amazes people. and it's quite a remarkable experience. And also in 2016, it was selected as one of the 10 best demos across Intel. And Intel is quite a large company, so there were like 100,000 plus people. So it's an important achievement, it's an important milestone. And we basically made it to the front cover of the brand book for that year as well as the back cover. And inside we have a nice. This one has about 20 to 21 different projects and demos that are being talked about. And basically, we also have a very nice coverage, like a big 2-page coverage in there, which is fantastic for us. This is a big honor for us. And another honor was it was also nominated as one of the top demos for excellence in bringing new experiences or technical innovation to market. One of Intel Lab's most prestigious awards. But I'll tell you an interesting one, last one, but not the least one for sure. We were always asked, in all this journey, in all of the trips that we did with the dress, and we were always asked this one question. What's the point? People were very blunt about, what's the point? This is all well, nice looking dress, a servo there, a servo here and everything, which is all well and good. You can't wear this. I can't buy this dress. It's not comfortable. You can't even sit in the dress. All very valid points, and and they're good questions. And our starting point was never to achieve any of those objectives. Our primary focus was to give something to the developer to show the potential of what could be achieved with an SoC like Intel Edison. That was our starting point. Ezra Tuğba, the brand, they never actually wanted to sell this. They didn't want to commercialize that first. They had some ideas on, worries on they would like to do this, but none of the parties actually had looked at it from that perspective. And it was a valid question at the end of it. It's a dress, right? And it should have a purpose as well, rather than just entertaining the crowds. But the surprising thing to me is really sometimes the experience you bring to the market. You do something, it has an impact, people love it, but you have no clue of where else it can potentially go. And the market actually tells you where it should go or where it can potentially go. Certainly, this was the case in Ezra Tuğba, because Ezra Tuğba brand actually got a dress order of the butterfly dress as a wedding dress. And that's where there was one potential market for this, because when you think about a wedding dress, it fits perfectly to what we've done. Like, you wear it once, you don't have to worry about being comfortable in it. You don't have to worry about washing it. You just wear it once, but you want to put it in your closet and you open it and look at it every now and then and still appreciate it. Still think about it. It brings back good memories. So this dress was like a perfect thing. That was sort of like the people's response to how this dress could potentially be commercialized, which was an amazing thing to actually see. And when you look at it again, and it's like I said, we never imagined this dress, this concept would go so far, right? When we first started, I remember the first day we were discussing butterflies, like static butterflies, dynamic butterflies, flying ones, static ones, etc. We were always thinking about these, but we never thought it would go this far. And when I look back and ask myself why, what was the reason why was they managed to achieve this? Is really if you have true ownership, if you're willing to put the hard work there and you're persistent about it, you believe in the project, big or small, that you're working in, really the project pays off at some point by actually creating this impact and the inspiration that truly exceed what you were initially expecting. Right? And we certainly didn't have any expectations rather than doing a good job of it. And that was it. But this journey took us that far. And I always keep on talking about the journey and the destination. And really, I want to conclude by saying it's the destination. It's not the destination, but really the journey. And what I have been talking to you in the last 45 minutes is really about the journey itself. If it was the destination, I would only be able to present you with one slide, one of the previous slides, and that would be it. But I tried to give you 10 different takeaways from all of this experience, which all emerge from the journey itself. And sometimes as engineers, we really, that's something we may actually miss. While we're working on things, dealing with problems, we sometimes forget to enjoy the journey itself. And I certainly have the privilege of enjoying this journey. And it's still, to this date, even though it's been about 5-6 years since I delivered the project, it's still a very wonderful talking point with a lot of good memories, and it's still a source of inspiration for many of my engineering colleagues as well. So I hope you enjoyed this conversation. I hope you found something entertaining and informative for yourself. And with that, I would like to thank you. And I also included a link there in case you want to have a little bit more, sort of like in case you haven't seen it, about the technical details of the dress. And I'll be more than happy to answer any questions you might have. Thank you.
Thank you so much, Dr. Shah.
Sure.
Guys, if you have any questions, you can maybe drop it on the chat now. Maybe until we get questions, Doctor, first of all, I would love to say that this is truly inspiring. The session was really interesting. Had had our full attention then throughout the entire session, so it was really interesting. Other than that, Dr. Shara, now it was a really interesting way how you used the Intel Edison chip for this particular uh, scenario. Are there any different applications that you've done with this Intel Edison chip? Maybe you can share some more information on that.
Sure, Krishmi. Actually, that's a great question. And while we were, even though today I decided to talk about the butterfly experience, there was another parallel experience that we were developing at the time for another designer. That designer was mainly developing like a 3D cast, basically, like a splint that you could wear around your arm. And really, it was sort of like that designer was trying to develop a solution for cerebral palsy. And what they were trying to do is in the cast itself, this point on the human wrist is where, cerebral palsy, for people who don't know, basically it's an involuntary sort of like flexing of the hand and curling of the hand, basically, for like some of the patients. And basically the doctor then injects Botox to actually recover the hand to its original shape. But the injection of the Botox needs to happen at a particular time, at a particular tension point. So what this cast would do, in effect, was to measure and monitor this pressure point there to understand how much that curling is happening and to call the patient to the doctor's office in a timely way to actually administer the Botox treatment. Rather than sort of having these weekly or bi-weekly trip to the doctor's office. So that was another sort of like a healthcare related application we developed, again with Intel Edison, again with the same card. So that's why while developing this card, I mean, I didn't mention this during our talk, but it has got some redundancy in terms of like ADC controllers, etc. So what we put on this card was intentionally to cover both projects at the same time. So basically they were like all in parallel lines. This one had like more sort of like tighter timelines. So I think the experience here is slightly different than the splint, but certainly that was another project that we also demonstrated at different venues, which got a lot of attention. And that was more useful from a utility perspective for most viewers. So they appreciated that one more than the butterfly dress in some instances.
Looks like we don't have much questions coming in.
Sure.
So I suppose we can conclude. Thank you so much again for the amazing session, Dr. Chara. I really appreciate you taking your time off your busy schedule to be with us here today. Like I said, it was very interesting to see the journey towards designing this butterfly dress from the incubation stage, then the rapid prototyping, and eventually seeing it to success. Something really valuable is how also how you kept working towards a vision even when it seemed very blurry at first. Truly amazing, and the perseverance and the faith you had throughout the journey, which eventually led to the outcome.
Absolutely.
And how focusing on the what's first rather than the hows. And most importantly, one more thing as engineers we can surely take home is the fact that working on technology alone might not deliver a product a consumer wants. Similar to this case where Dr. Shah worked very closely with experts in the fashion industry and found it easier to deliver the required outcome. Similarly, I think we also can infuse the same in our day-to-day lives when developing products, be it manufacturing, healthcare, agriculture, or whatever it is. You can always deliver a good product when you work together to get expertise in all areas related to the product to basically get them to work together. I guess collaboration is definitely a key. So
yeah, fantastic. Thanks for takeaways, Krishmi. Thank you for that. Thank you for that. Yeah. And by the way, if I know coming up with questions might be difficult, but for anyone who would like to reach out to me offline, they're more than welcome. I'll be more than happy to address any questions offline. So please do share my details with our colleagues, and I'll be happy to address the questions they might
Yes,
have.
yes, doctor. Yes. So I'll take a few more minutes and I'll just thank our organizers also today, the Dialogue Innovation Foundry and the 5G Innovation Centers in collaboration with Dialogue Academy for helping us organize this today. And last but not least, to everyone who attended the session today, thank you so much for being such a wonderful audience. And we really hope that you learned something. And since you guys did not have any questions, like Doctor said, if you guys can always drop us an email on our Innovation Foundry email address, and I'll also share Dr. Chara's information with you guys as well, and we can surely get back to you. And
Thank you.
for anybody who missed the session today, a recording of the session will be available on our Innovation Foundry YouTube channel. So you can always check it out as well. So I guess Dr. Shara, I'll share the same link with you as well. Maybe you can share it with your colleagues also. Yeah, so that should be it. We can conclude. We have also several more interesting sessions planned during the upcoming weeks about various technology trends. So be sure to keep an eye on them as well. So once again, thank you so much everyone for joining in. Hope you have a good day. And Dr. Shara, hope you enjoy your night. Good night.
Thank you so much for having me. It was a great pleasure. Take care of yourselves and speak to you soon.
Thank you so much, Doctor.
Thank you.
You.
Bye.